Hey guys, my name is Kimberly, and I'm really excited to be a part of this two-part lecture with you. I'm a mechanical engineering student at Mississippi State University, and my counterpart Lincoln, who's going to join us a little bit later in the video, is an industrial engineering student at MSU as well. We're going to be covering CAD, how to take a conceptual drawing, turn it into a CAD file using a CAD software, and then how to import that into a 3D printer and come out with a final product. So let's talk about CAD a little bit. Computer-aided design, what is that? So in short, it creates precision drawings and technical illustrations, and it's used by a wide range of professions. Engineers, drafters, architects, artists, to name a few. And they do those in two-dimensional and three-dimensional drawings and illustrations. So what kind of software out there does CAD files? Well, there's a plethora. There's too many to name. There's Solidworks, there's Autodesk, which uses AutoCAD, there is Fusion 360, Rhino, and many, many, many more. So we're going to be focusing on Solidworks for this lecture. So within Solidworks, as explained earlier, we create two-dimensional and three-dimensional drawings or illustrations. And those drawings or illustrations are comprised of parts or assemblies. Well, what are those and how do they differ? So a part is a piece. Think of it as one singular item. If you purchase a chair and you have to put it together, the part or the piece is one chair leg. It is one seat. It is one bolt. So it is one singular item. The assembly is the entire chair. It is all of the parts or pieces that make up that chair, the relationship between those parts and pieces, and how that big picture looks. That's what the assembly is. It's the assembly of the parts and pieces. And so that's done in 2D or 3D, either one. So what does this mean big picture besides putting together a chair? So mass manufacturing. If you are drinking a Coca-Cola right now from a Coke bottle, it's likely that that Coke bottle came from a CAD file. Or if you are very lucky and you get a ride in a fighter jet, then that fighter jet also came from a CAD file, and everything in between is all around us. So what is something else? SolidWorks in particular is used to simulate and analyze those parts and pieces and their performance. So what does that mean? Well, back to our chair example, you have that bolt. So if you have that bolt in SolidWorks and you apply a force or a weight to it, then you could determine that failure point or when it breaks. And that aids you in determining that total weight limit for that chair. So that's pretty cool. And then something that everyone is familiar with is how an architect uses it. And an architect uses it by making blueprints, designing homes, the one that you're in now, or the office that you visit, or the retail establishment, or the classroom that you learn in. So all of those are made into blueprints and then constructed. So that's a widely known use for CAD files. Okay, so why don't we do a conceptual drawing, and then we will send that to Lincoln, and then he will show you a brief overview of SolidWorks, and then how to create that CAD file within SolidWorks, and then how you get to a final product through a 3D printer. Okay, so here's the conceptual design. As you know, we're going through COVID-19, and nurses and healthcare workers and frontline workers are wearing PPE all day, personal protection equipment. And those masks with the loop around the ear creates a lot of strain on the ear, so we wanted to adopt this design and to help alleviate that strain on the ears. So it's going to put the force on the back of the head. So I just drew this. It's very rough. It doesn't have to be exact when it's a conceptual design. We really just want to get our point across and get the scale as close as we can so that we can convey which parts are bigger, which parts are shorter, and which parts are the same size. So I drew this. We want these loops here to be printed on top. So think of when a 3D printer or any printer prints, it prints the first layer and then it prints on top of that. So we want these loops to be printed on top of this base. So I drew them on top to illustrate that. I also wasn't able to center this very rough sketch of Mississippi in here. So I just put my parameters right there, put a dotted line and a C to illustrate to Lincoln that I want this to be centered. Okay, and so yeah, here's the little loops. There's 5 on each side. It's very simple, and it's just going to go across the back of the head. So let's go ahead and send this to Lincoln. He'll convert it into a Solidworks file and then show you the final product from a 3D printer.
Hey guys, my name is Lincoln, and I'm going to be showing you how to take that drawing that Kimberly just made and import it into SolidWorks and turn it into a 3D part. So just to give it a little bit of change when compared to the actual design, we changed the number of clips that would be on each one and the dimensions that we would actually use, so that you can kind of see a contrast between what I make in this one and the one that I show you at the end. So when you open up SolidWorks, you just have the sort of home page for it, and we're going to go ahead and create a new part. Now there are 3 different items here. There's a drawing, an assembly, and a part. And I'll just talk about them, even though y'all know that I'm going to click on part. So a drawing is a 2D representation of any of the things in the real world, like bolts. So whenever you want someone to create a bolt for you or create a hinge for you or anything like that, you have to give them a sheet of paper with some dimensions. So in a machine shop or something like that, they can actually look at it and say, all right, this is supposed to be this long and this is supposed to be shaped like this. So that's what you'll make a drawing for. A part is just the 3D representation of what the contents of that drawing is. So you can actually move back and forth between drawings and parts. Neither one has to be done first. You can use a drawing to help you make a part, and then use a part to make drawings. And just back and forth as you make modifications to your design. Now an assembly is a collection of parts, so it's the many pieces that make the whole. So if I wanted to make a couch, and then I would need different screws, different bolts, different pieces of wood, and that would all be assembled in the assembly. So let's go ahead and create a part, and we're going to get started making this mask clip. So whenever we start out, we come to 3 different planes for 3 different dimensions. So I want to create a sketch on one of these planes. The reason why I need to make a sketch is because we can't really draw in 3D. We have to draw in 2D and then make it 3D. So I'm going to click on this front plane, which is where I want my sketch to be on, and I'm going to click on Sketch. Now this is my canvas. This is my sheet of paper. And I'm able to draw on it with many different tools. So I can use a line, a square, I can use different circular designs, and then I can just use some crazier designs. So what I'm going to do to make this a little bit easier is I'd like to pull her drawing into SolidWorks so that I can simply just kind of sketch over it. That would make things a lot simpler. So we're going to go down to this Sketch Tools, and I'm going to say I want a sketch picture. And I'm going to pull in her file. Now, it's a little bit big, so let's go ahead and shrink it down. And so I shrunk it down and I centered it. Now the reason why I centered it is going to help me save a lot of time later. So it's best to kind of you get best practices when working with these programs just over time as you use them. So this is just a rough sketch of what it would kind of look like, and I need to turn this into something that is a little more precise. These lines need to be straighter, things like that. So we're just going to start off with creating some lines. Now, since this back piece actually doesn't go as far out as the clips, we need the back piece to come all the way out here. So I'm going to start by telling it I want to go from here to here, kind of just through that where it would begin and end. We're going to do that again with another line, but we're going to start from here and we're going to go to here. So just to make sure that these are parallel, because we want our shape to be correct, we're going to go ahead and click both of them and tell them to be parallel. So they actually pulled that down a little bit. We can actually fix this and make it work right by just kind of pulling these around to get them how we want them. So that's how I'm wanting them right there. And we're going to go ahead and start making the rest of it. So how are we going to do that? Well, let's go ahead and make this little piece right here. Oop, wanted us to make an arc right there. Let's click it again. We're going to tell it, well, let's go ahead and just make it right down to here. That looks good to me. And come right over here to close it out on the bottom. And then we're going to do the same thing on the top. Now, one important thing is these yellow lines. So the yellow line is telling me that if I place the end of the line here, the line is going to be parallel with the line I came off of. So these lines are both parallel. That's really convenient so that I don't actually have to go in and tell it to be parallel. So let's go ahead. These should be parallel. They're good. And also you can see this little line here. This is telling me that these lines are horizontal. So obviously they would be parallel if they're both horizontal. So we've gone ahead and gotten the base for it created. So let's start and get a few of these clips done. So what I'm going to do is how it kind of looks to me. So I'm just going to put a line kind of up there. And I'm going to put a 3-point arc, so a semicircle from here to here. And it'll be, a little something like maybe that. So if we do that, we can go ahead and tell it to close out here. And then put us another line that goes through. And then we're going to do something a little more creative to try to get this down here. So I could redraw this out kind of down here, and that would take me a little bit of time. But I would rather use something called a mirror. So a mirror, obviously you would see the opposite reflection of something. So what I'm going to do is I'm going to say mirror entities. And I'm going to tell it I want this, this, and this to be mirrored about. Actually, let's go ahead and create a line first. I'm getting a little ahead of myself. We're going to create a line that we're going to use to mirror across. So let's click mirror again and select our lines. And then say, let's mirror it about this line. You notice that it puts all of it down here and it sort of connects them together. It has the same spacing and everything. And we're going to say, okay. All right, there's our first clip. So there's a limitation in the SolidWorks functionality right now that you can't actually, normally I would be able to take this one piece right here and copy it all the way down here effortlessly. But there's some issues with the people who work at SolidWorks and making that work, but we can find some few ways around it. So what is we're going to tell it to copy. I'm going to say, all right, I want it to copy all this not that. And we're going to say, where do we want to copy it to? Well, I still want it to be attached to this line, so I'm going to click on this dot and just move it to here. So I decided to time skip us ahead to where you wouldn't actually have to watch me copy each of these to their selected locations. But as you can see, we have all the clips in. So with the clips in the base, there's only a few more things we have to do. We have to create this little cutout, the Mississippi cutout, and we have to get everything else over here. So let's go ahead and get this cut out. And we're going to go ahead and start probably from this side. Do it just kind of like that. And then we're going to do the Mississippi cutout. So Mississippi cutout will be just like this. And as you can see, this Mississippi cutout is actually 100% accurate to the real Mississippi. So, like, no need to change it. Well, except for that little extra part right there. That's just some artistic creativity. So you notice that the Mississippi is actually not in the center, and she told me that she wanted that in the center. So what we're going to do is I'm going to say, all right, I want to move some entities. I want this, this, and all of these to move. And I want them to move from this little center point to this center plane. I told you before that being in the center was important. This is one of the reasons why. The next reason is actually more important. And that is we're going to use the same mirror that we did over here, and we're going to move all of this to this side. And that's going to save us a ton of time. So we're going to go to mirror, and we're going to select a bunch of stuff. So it selected a little bit more than we wanted, but that's okay. We can just deselect these. And we're going to say, all right, I want it to mirror about it in a line. Well, you're saying, Lincoln, where's the line? You had to draw a line here. Well, we're going to use the center plane as our line. So I click on that, and they're right over here. So let's go ahead and click OK. Now everything's in place. So now that our sketch is done, let's go ahead and exit. Alright, so you can't really see it all that well unless I'm moving it. But we're going to get rid of that drawing now that we're done using it. So let's go get rid of this drawing. Now we just have our sketch. Now, to turn this from 2D to 3D, we have to do what's called extrusion. So we're going to go over here to Features, and we're going to say Extrude Ball Space. Now, we come down here and we say, what do we want to extrude? Well, there's a lot of things I want to extrude. I want this to come out, this, all the way through here. Now, as I mentioned before, the clips come out a little bit further, so we're going to do the clips last. And we're just going to do the base first. Okay, so we're going to just kind of cut this down a little bit. And there's our base with our little Mississippi cutout. Now let's go ahead and get the clips out. So we're going to extrude again, and we're going to click each one of these to bring them out. Okay, we got half of them. Unfortunately, no time skip here. We gotta get each one of these. I know this is compelling. Okay, so we've come out the same distance as the actual base, so let's kind of go a little bit further so that we can just kind of see the difference. Now, none of these values are exact, obviously. It's not going to be 0.075 inches. But whenever we're actually making the real part, we're going to worry about making the dimensions exact. So we're going to click OK. And now we have our clips. I'll get rid of these planes. Well, I won't get rid of them. I'll hide them so that we can see it a little bit better. And this is the actual, well, this is the mock-up drawing that we did to kind of see what the piece would look like whenever we create it in just about 10 or 15 minutes. So I'm going to go ahead and show you what the real version is with the final version. That one took a little bit longer. You're going to see more detail in the Mississippi. The dimensions are going to be very nice. So let me go ahead and show that to you. Alright, so this is the real version. This is the one that we're actually putting in. So as you can see, the Mississippi is really detailed. There are a few clips on it, and it looks really nice. And that's all for the lesson. And I'll go ahead and give it back to Kimberly and let her just kind of give y'all a homework assignment that I think will be pretty exciting. Thanks.
Isn't that pretty cool? How you can go from an unrecognizable state of Mississippi and a drawing that doesn't look like it could amount to anything into a device that's really going to help a group of people that really need it right now. So this is where the fun part comes in, your homework. It's due 24 April at 12 p.m. And we need you to come up with a conceptual design and email it to your teacher to replace this state of Mississippi right here. So be thinking about what you would want to put in there and then email it to your teacher by the due date. And then Lincoln and I are going to select the design. We're going to put it into Solidworks, get the CAD file, and then 3D print it in one of these. We're excited to see what you have to submit, and we'll see you next week for the second part of this lecture.